All right, ladies and gentlemen, I do apologize for all of that. That was kind of strange. I wonder if I will be getting into this one back up. Yep. So we're back on. I do apologize. I'll have to go and see. Actually, I didn't check. I got to go and do my math. I was like, oh, I was having a little bit issues with that. So I was like, hey, you know what? Let me go ahead and check my math. Oh, at least like I'm back on with that. That's good. And then it looks like the other one is unfortunately going through. So I do apologize for that. I had a little issue with my internet that kind of went through. And so I do apologize. I think when I kind of connected my new kind of studio around, I was just bragging about, hey, I don't have my green screen. And I was just bragging about all that kind of stuff. And then I went ahead and take a look and I realized that I don't think I had a direct connect. So something was going with my Wi-Fi. So I had to go ahead and direct connect from there. So I do apologize for all of that, guys, but we are back in there. Let me go ahead and get into the to the math, and let's go ahead and wrap this up. All right. Okay, so we talked about perfect student. We got that in there. I bet you're in your bike got together. Yes. Thank you very much, Addie. Well, hey, Christopher and Jack, thank you guys for showing up. And I do apologize for those of you that were on the last stream. It looks like everybody is back over. Okay, so let's go ahead and finish this one up. Do you know if the unit? Do you know if the unit after trigonometric equation is algebra 2? I do not know, but typically trig is at the end of algebra 2, but you only need to ask once on that. Okay, so let's go ahead and let's actually get some math done. So we do have a couple questions. We have some logarithms, a vertex, a geometry one, this question, and then 5 and 6. So, and 7. So yeah, definitely. Hamza, thank you. You're a huge help and I appreciate it. At least that I can do is buy a cup. Well, thank you very much, Hamza. I very much appreciate that. Thank you so much. Thank you. That was very nice of you. Do you have any questions about physics? No, I do not have any questions about physics, nor do I usually take questions on physics because that is not a topic that I currently teach. All right, so question number 1 is about the logarithms. Now, the first thing that I would recommend doing for this one is using your logs or your rules of logarithms. So we can take the 2, bring that on front, okay? So, and then we can also use the rules of logarithms to go ahead and rewrite this. So we could say that x minus 1 quantity squared, and we could say the log. Actually, there we go. We can write the log base 2, and then we bring this 2 in front of x minus 1 quantity squared equals 1 minus x. Okay. Oh, equals log of 1 minus x. Log base 2 of 1 minus x. Okay. So now we can use the one-to-one property where we can just break up out these. So the one-to-one property says is basically when you have log equal to another log, then your arguments can just be equal to each other. So we can just rewrite this. I can expand this to be x squared minus 2x plus 1 equals 1 minus x. Okay, now we're going to want to get these over to the same side. Let's go ahead and do a little distributive property. 2x squared minus 4x plus 2 equals 1 minus x. Plus x minus 1, that's a 2, right? Yeah, it is a 2. Okay, so we have a 2x squared minus 3x plus 1. Okay, and then that's going to equal 0. So again, we want to go ahead and solve. So now we're going to go ahead and say which ones are these going to equal to, right? So we could say, let's say I could do a factor this, say 2x. This will be an x. Let's say they have to be multiplied to be 1. So that's going to be a minus 1 and a minus 1. Right? And then that would give you a negative 3x equals 0. Okay? So then we have a 2x minus 1 equals 0 and a x minus 1 equals 0. So x equals 1/2 and x equals 1. And then you could plug them back in. However, if you plug them back in, what you recognize is you cannot take the logarithm here of a negative number, right? So we can't plug in 1/2, but we could plug in 0. Actually, 2 to what power is going to equal 0? Actually, I'm wondering if that's going to give us anything. No, that's going to be error domain, and you can't have a negative number either. So I'm assuming that's why we're going to get no solution, right? Because there's no power that you can take that's going to take that to a solution. So these numbers, when you plug them back in, they don't make the argument true, right? Because when you plug in 1/2 or 1, that's going to give you a -1. That's going to make a -1 or to 0. And obviously, you guys, you can see that you cannot take the logarithm to go ahead and work with that, which we'll go ahead and continue on for as well. All right, the next one is find, so that's why we have no, even though we were able to solve it, we don't have any solutions. The next one is find the vertex. So in this case, all we're simply going to do is y equals so first thing you're going to do is actually expand this, because this is what we call in factored form. And factored form is great to find the x-intercepts. But it's not really great to be able to identify the vertex. So we have y equals, this will be an x squared minus 6x plus 5. Okay, now you can complete the square, put it into vertex form, or you could just do, you could find the vertex using the vertex using the formula. So I could say y equals, let's see, I can complete the square here, x squared minus 6x, divide by 2, that's a 3, plus 9. Plus 5 minus 9. So y equals, so basically I did this to be divided by 2 squared. My penmanship has been really bad. So -6 divided by 2 squared. Okay, so -6 divided by 2 is a 3. 3 squared is 9. That's why I added the 9 and I subtracted the 9. And then here I can further factor this down. All right, so this becomes x minus 3, quantity squared, and therefore this is a -4. All right, question number 3. It's not a question, but I need an explanation of the triangle congruence postulates, and then right triangle theorem. I'm not sure about the right triangle theorem, but I wanted to, go on from there. Man, guys, I don't know what else to say. All right, so let's go ahead and, so on this one, I'm not really sure what else I can do for an explanation of the postulates. The couple things that I can say is, if we're going to, like the triangle congruence postulates, or I'm assuming like these theorems, basically the ways that we're looking at is we want to prove that two triangles are going to be congruent of each other. We want to look at like what is the necessary information that we can prove congruence. So let's look at the difference between similarity and congruence. Okay, now similarity just means that they are proportional to one another. They don't have to be exactly the same size and shape, but they are at least proportional. Now the two things that are going to provide similarity is going to be angle, 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 and I think that's it. Yes, that is going to prove similarity. I was trying to think. Yeah, that does prove. Okay, now for congruence, what we have is side, 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 angle, side, angle, side, angle. We have angle, angle, side. And then we have side, side, angle, but only if it is a right triangle, which would be our HL. So that is our hypotenuse leg theorem. So those are all the information. So if you have two triangles and you have and they are equal in measurement for what we have right there, then you could say those two triangles are congruent. You don't need to know all the sides of the triangle to show that they are all the same. And the same thing works for similarity. If you have two triangles that are going to, if you have two triangles that are just have the same angle, 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 then you can say that they are similar or going to be proportional to one another. All right, question number 4. I decided to kind of go for this one, and I was like, figure mine as well. So it says the line 5, n and 1, -2 is parallel to the line 3x plus 2y minus 1 equals 0. What is the value of n? All right, so in this case, first thing we're going to want to do is find the slope for 3x plus 2n. So I have 3x plus 2y, so 3x plus 2y minus 1 equals 0. Okay, so first thing we're going to do is add a 1 to both sides. So 3x plus 2y equals 1. And then to solve for y, what we're going to do is subtract a 3x. And we have 2y equals a negative 3x plus 1. Divide by 2, divide by 2. And here I have y equals a negative 3/2 x plus a 1/2. Okay? Okay, so therefore our slope m equals a negative 3/2. So that is the slope that we are trying to prove. Now, the next thing is what we're going to look at is they say these 2 points. So if we want to find like the slope here, then we could call this like x1, y1. And we could call this x2, y2. Okay, because remember the slope is going to be the change in y over the change of x. So y2 minus y1 over x2 minus x1. Okay, so we have m equals let's see here. So I have -2 minus n divided by 1 minus 5. Okay, and then that is going to equal a negative 3/2. Okay, so basically here, all we simply want to do is be able to solve for m. All right, so what I'm going to do is I'm going to delete that. All right, and now what we want to do is just kind of simplify this. So we have a -2 minus n. This comes a -4 equals a negative 3/2. All right, so we can multiply by a -4 on both sides. Then I have a -2 minus n is equal to, let's see, that divides out. That becomes that was a -2. Yeah, that's just a positive 2. So that's a -2, so that equals a 6. And then we could add a 2. Add a 2, negative n equals 8. Divide by -1, divide by -1. N equals -8. So hopefully I didn't make any mathematical mistakes there. My math, I don't know why, it seems a little off making this in. All right, question number 5 says, if a 5-meter ladder is to be placed against a wall at an angle of elevation of 75 degrees. Okay, so let's make the ladder. There's the wall. Okay, and therefore we have 75 degrees. There's the wall. How far should the foot of the ladder be placed from the wall? Okay, so let's call that F. And then how high will this ladder reach on the wall? Let's call that H. Okay, make a sketch to show the information. So there's a sketch. And basically what we're looking for is to find the missing sides. So again, the ladder with the wall is going to make a 90-degree angle, assuming. So we know that's 75 degrees. And it says a 5-meter ladder. Okay, so we want to find F. And we want to find H. So to find F, what we want to use is use cosine. So we can say the cosine of 75 degrees is equal to F over 5. And then to find H, we could say that's going to be sine. Sine of 75 degrees is equal to H over 5. Okay, so now in both cases, we'd multiply by 5. So we could say F equals a 5 times the cosine of 75 degrees. And here we could say H equals 5 times the sine of 75 degrees. All right, so therefore we'll do 5 times the cosine. Make sure I'm in degree mode. Oh yeah, 75 degrees. And that's going to be F equals 1.29. And I guess that's in meters, right? Let's round to the near. Does it say? Oh, to the near 100th. Okay, so I need to do, what's the nearest? 10th, so 9, 4. And then H equals 5 times the sine of 75. And that's 4.82, but that'd be rounded up, so that'd be 8.3 meters because that gets rounded actually up. So we'll do 8.30. meters. All right. Next one. Write each equation in exponential form. So there's kind of something really important to understand for each of these two is when you want to write something in exponential form, we need to understand the logarithm, right? So, if we had like 2 to the third power, we know that equals 8. Now, if we want to write that in logarithmic form, we keep the base the same, log base 2 of 8 equals 3. Okay, so that's a way for saying 2 raised to what power would equal 2 raised to what power equals 8. That's what the logarithm represents. Now, in these two scenarios, we have the logarithm as well as the natural logarithm. So it's important to understand what the base is in this case. In this case, the base is 10, and in this case, the base is e. Okay, that is what is going to be assumed for students to be able to understand for these. So in this case, I'll have 10 raised to the 2.301 equals the argument, which is 200. And in this case, we'll have e raised to the 3.22 is equal to 25. And then last one was submitted by Kulo, which was what is the period of the function for the cosecant of 8x? So the period of cosecant for secant for for sine and for cosine is 2 pi divided by b. So b is going to be what is right in front of your x, what is being multiplied. So in this case, it's just going to be 2 pi divided by 8. You can reduce that to pi over 4. And again, the period is how long it takes the graph to repeat itself. And there you go. All right, ladies and gentlemen. Well, I know many of you have your exams coming up. I did not post the Discord link nor my question link, but if you guys do have questions coming up, if you guys still have exams, feel free to go into the description of this live stream and go ahead and check out the link where you guys can go ahead and submit your questions. I might as well put it in here now. So therefore, you guys can definitely go ahead and submit your questions. If you guys have questions for next week, I will be more than happy to answer those questions for you, as well as if you want to go ahead and hop over to the Discord unit, the Discord server, and therefore you guys can go ahead and take a look at what we have going on over there, where you guys can submit questions each and every day of the week. We have students that are helping each other out, and it is a great way for you guys to be able to get help with your math. So I definitely recommend that you guys go ahead and check that out as well. But otherwise, guys, I have school tomorrow, so I am going to get ready and prepared for that. Thank you so much for joining in the live stream. I do apologize for the internet issues for the other stream, but again, I appreciate you guys joining, and I look forward to seeing you guys next week. All right, cheers.